Hello, my name is Dow Codes. Today we're going to be talking about the dry and solid coding principles. So these are practical rules for writing maintainable, scalable, interview-ready code and production-ready code. So the reason we're going to be talking about this today is because I think as agentic AI becomes more and more powerful and code is getting cheaper, good code is actually getting more scarce, right? A good understanding of these fundamentals and other underlying principles are going to help you with both agentic and non-agentic coding. These principles are just how you engineer good systems and good code. If you're not using dry or solid, or if you don't know what they are, but you're going out to Claude and you're prompting in ways that it's forcing itself to violate dry and solid, you are not helping it align with good solid principles. You yourself are not understanding the fundamental principles that make for good code. So by knowing these principles and others, but I think dry and solid are kind of the foundational principles of good coding, you are going to help your systems be better. You are going to help your repositories be better just by doing these two things and kind of double checking with yourself. Hey, does this code make sense? Does it smell okay? So we're going to start with dry. So dry is don't repeat yourself. Keep each rule, keep each service, keep each logic path in one location. You should be reusing functions is the main reason that functions are so prolific and why methods are so important to use, right? That we don't just have major 10,000 line methods because logic is going to be used. The other one, they're less so, but constants, config, validation, these things should also be centralized. Copy pasting any sort of code, if you're not changing it, is just bad practice, right? It's going to help you get more code out there, and agents will also help you. Hey, write this service, but you actually don't know that you have the same exact service over here. That's going to be a problem in the long run, because if you have, whether it's bugs that occur in this one hot path, but then you've copied and pasted it over here, you've now have duplicated bugs, or you need to have, hey, I'm going to enhance this feature, but now actually this feature and this service path is in 7 different places, but it's slightly different everywhere because we didn't centralize the logic the right way. It's going to be really hard to upgrade. So that's dry. Moving on to solid. Solid is SOLID. So that's 5 different object-oriented design principles that are going to help with flexibility and maintainability of your code. Each principle is going to help reduce coupling in different ways, but each is just as important as the rest. So to start with, I do think the most important is single responsibility principle. This driving force of one reason or purpose per class is going to force you down a path where your code is more maintainable and more readable. Instead of having major services that could be 10,000 lines long, not saying that any time you have a 10,000 line file is wrong, but your code, if you know, and you could be pointing to what files, and your agent can then understand, hey, this service is supposed to be doing this, and then I have reuse available, and I have good patterns throughout my repository. Single responsibility principle is going to help a lot with that. If you have an authentication service and then a user service, the boundary can be fuzzy if you don't make it clear that, hey, when I'm authenticating, I'm over here, and then I'm in the user service, I'm doing things on the user for like CRUD reasons. So the next is the open and close principle. This is extending behavior without editing core code. This is really about maintainability and scalability of your code. If I have a core service that I have an API service over, and then I suddenly change core code or change API, maybe the method signature changes, I've now broken all of the consumers, and I have to go through and change it. But could I, instead of extended this behavior in the core code, added an extension method in C#, or maybe just a new overload? Think about those things when you're trying to change core code and trying to write good APIs. Now, the Liskov substitution principle is kind of the same idea, where it's maintainability on what's the blast radius. So subtypes must preserve expected behavior. If I derive a class and I'm in a chain of hierarchy, I shouldn't be rewriting and changing the core implementation or the expected behavior of that class. Now, if I have an authentication service and the expected behavior is to persist something to the database for like an access token for a user and a refresh token, but then I come and rewrite this whole service But it's not that I'm changing you, because you can change implementations 100%. That is the reason we have subtypes. But if I'm changing the hot paths and I'm changing everything to do with the rest of the hierarchy, that is going to be a problem, because it's going to be a subtle bug of, oh, why I happen to pick this subtype, right? If a collection, so I collection is an interface in C#. If the list holds multiple different items, but then I come and write a set, right? It's a set, a different type of collection, but actually don't hold any of the items. You just put them in there and take them out. It doesn't actually do anything in memory, and I can never access the set again. The expected behavior of the collection, I still need to be able to get the things in the collection. So if I then use the set for a reason, the consumer of that code of an I collection no longer is getting the expected behavior of an I collection. Another one is an interface segregation principle. This is small focus interfaces for each client. If I have major parts of an implementation of my interface that are unused for that client, for that concrete implementation, I should have a different interface or split out the interface. Having a massive interface that is derived or implemented multiple times is only going to confuse the person of, well, I kind of need this service, but now I don't know which one to pick, and now I have to pick 3 different ones because this one does this half of it correctly, and then this half, and then this part is a little weird, but I need it this implementation here. Small focus interfaces allow each client to know better who is delegating what. Now, finally, the dependency inversion principle, dependent on abstractions, not implementations. This allows you to have modular code, right? If I am depending on concrete everywhere, now I've tied myself to that implementation. But if I'm on abstractions and I have small focused interfaces and each class is has a single reason, my code becomes really modular. I can switch really quickly, get something up running or new features, because my purposes in my class are very clear from my interface perspective, and the dependency inversion allows me to change out implementations really quickly or just iterate better. And also, it's a readable thing, right? For when you don't need lists, but you just need a collection, use a collection, right? It allows you to change things under the covers without the end consumer really being affected. And that's why the open closed or the listcoff substitution actually matters, because if I'm depending on abstractions and I'm changing out what that subtype is, I don't want my subtype to suddenly just change everything about my code, right? There can be subtle differences and nuances, but in general, your expected behavior should stay. So dry and solid really complement each other, right? SRP, single responsibility, narrows responsibility to a class, but then dry keeps that responsibility in one place. So now I have a single responsibility. I can test that class well, and once I know that that class is good, I now know where to go to get that service, or to get that logic, or to get that expected behavior. OCP, which is open and close principle, supports safe extension through new classes, or extension method, right? These are both ways that I'm extending behavior, but I don't have to change the hot paths of my code. Dependency inversion enables testable design via interfaces. This is the other big thing about solid and dry. When you have these principles, your code becomes testable, so much more testable than spaghetti massive services, right? If I have a massive service with 10 million private statics that I need to go through, how can I test that? I have to mock up everything. I have to have it go through the end-to-end test basically to do a test. But if I have open and close principle and single responsibility and the interface and the dependency inversion and the listcoff, I can get testable code really quick because I know what that class is supposed to do and I have a reason for it and I'm going through it. Now, this doesn't mean you're not going to have hard, complex code, right? Abstractions are just changing the levels where that code is going to be. Your code is still going to be complex if you have a complex problem. But what this allows you to do is target that complex code in a better way. Now, combined, they're going to also reduce regression risk, right? When you make major changes to the concrete implementations, you can still expect the same behaviors with your interfaces. So a little workflow here. Find your duplication, extract the shared behavior, define your clear abstractions, apply your solid checks, and add tests, right? Once you have solid, you can write better tests. Now, finding duplication isn't always straightforward, right? Maybe it's not the exact same code, but we've talked about design principles other times, template method pattern, the strategy pattern. These kind of things help you find that duplication of there's some shared behavior. It has some shared structure. So now when you're doing this, there are a couple common mistakes to avoid. Abstracting too early or blindly can create a lot of extra complexity. Now, once you get more familiar with this kind of coding, you'll know where the complexity needs to be. You know where the abstractions need to be, but early on, I'll admit I'm definitely until it hurts, I'm not going to do it. I don't want to over abstract if I can get away with it, because that's going to hurt me more than it is going to help me. Now, applying dry blindly can also over-engineer simple code. So use this as a tool, just like all the other things, right? These are underlying principles to help you with good maintainable code, but make it work, make it good, make it fast. Make it good is dry and solid, right? Make it right first. Make it work. Large interface misuse, and direct concrete dependencies can also hurt you in different ways, right? We've talked about those above, and I won't go much more into the details, but just wanted to have a high level discussion about dry and solid. And if this video helps, then drop a comment. But if you're looking at a code base that is just really hard to grok, even with AI tools, just pick one duplicated rule and just start to apply it. And it's going to, once you start applying one, it's going to start to force you to do the others, right? If I have a single responsibility, well, I kind of need an interface for this now. Or, man, I really want to have good interfaces, but this interface is huge, and now I have to refactor all these different things. Well, then make it smaller. Have this in interface segregation where these are focused interfaces for each client. So that's going to be it for today. Hope that helps. But as always, happy coding.